We are at the Titan Missile Museum. Hello. Yeah, it's so crowded here. Super crowded. I think I'll go for a walk. Well, that's the top of the silo where you go down.
All right, let's go downstairs. As we're walking through here, and you're looking at the complexity of this place.
There are multiple
No
doors.
computers, no calculators.
Multiple doors. They're letting me go in by myself. Pretty cool. Here's the big shock absorbers that are holding everything. You're on this little, that's the missile way back there. And everything you're walking in is being suspended. You're being suspended on shock things. And now here's the very edge of this is where the crew launched the missile from. And they're suspended by these massive, massive springs. This is pretty cool. They're letting me in here by myself. And here's launch control of a Titan II missile. The stairs, upstairs crew quarters, downstairs is more equipment. And this is amazing. I believe the officer sat here and his key's over there. And this is the other person. They sat here and their key is right there.
Come on in, folks, don't be shy. We're going to launch a nuclear weapon together. Young lady,
Yes.
you're not afraid to blow up the city, right?
Oh, no, of course not.
You look like the type that would blow up the city. Right? Right? Okay, sit over there. All right, folks, before we talk about this crew, let's talk about this facility. Okay, you are now in that dome-shaped structure that you saw on the diagram. Crew's quarters is up here. 2 double bunks, a small bathroom, and a very small kitchen. Okay? The crew came here for 24-hour shifts, 10 24-hour shifts a month. Okay, they weren't doing much sleeping up there, so the bunks really didn't matter. If they wanted to take a cat nap, that was fine. Nobody was sleeping for 8 hours. Okay, down below, we have our heavy equipment room. And down below is where the similar pipe like that one is, only it's not covered with duct tape. That's covered with duct tape because we have air conditioning in here. Okay, now, that's the pipe you would have crawled through in order to get to that air shaft, which you would then climb to get out of here. All of this equipment around me is mission critical. We needed to launch our missile. The problem is when the shockwave hits the outside wall of that building, it's going to shake it so badly that all of this equipment will be destroyed. How did the Air Force figure out the way to protect all that? Very simple. When you walked in here, you crossed over a little hump. Okay, you probably didn't even notice it. That hump covers a 12-inch void. That void, or emptiness, goes all the way around this round room. That can only mean one thing. You're not attached to the walls of the building. You're floating right now, and you're floating on these little springs. There's 8 of them around the room. Now,
Little springs are huge.
well, now when the shockwave hits the exterior wall of the building, it's going to shake it like crazy. We don't care. Because in here, We can go as much as 18 inches up and down, and as much as 12 inches side to side, and you are not going to feel a thing. If you ever have a coffee on your console, you're not going to see a ripple in that coffee. During all that static, you're both going to look up or grab a...
It's liquid fuel.
Yes, this was the last liquid fuel missile we had.
It could be stored as liquid fuel.
Do you want me out of the way? Okay, I'll go this way.
That's why we were launching 3 minutes.
All right, here's the lock. This is the butterfly valve. This is half of the actual fuel line, and this is the lock they had. It was electronically controlled. Sent a signal here, locked it. Pretty neat.
Don't turn it.
And then here's the cabinet where the all the codes were kept. And this lock were the two different people, and one person didn't know the other one. So at the beginning of their shift, they'd put their own lock, they'd switch with the other people, put their own lock on, and when they got a code and they decoded their code for a launch, the final codes were inside here, and they needed the final codes in here and the keys. This little key was kept in there, and the other key right there was kept in there, and then the codes would be what would unlock this, and then the missile was ready to go when they turned those keys.
It was like this one, war materials, this one, polymers, this
Yeah,
one,
you're looking
fuels,
for strategic sites.
like this one, like medical supply.
I don't want your house.
All right, so this is we're leaving the control here, and these are blast doors. We're gonna walk through 2 blast doors. That blast door goes to the outside, and this blast door goes down to the missile. Now this whole thing is hanging. It's hanging by all these shock absorbers.
Yeah. So if the shock wave hits, instead of it becoming a slinky, it's going to stay stable.
Be some movement here. An interesting way of getting some movement. More controls. More movement. And now we are in. Here she is.
All right, folks, what you're looking at is an authentic Titan II missile. That is not a model of fake or a mock-up. It's the real thing. That missile, question you should be asking about this missile is how in the world did the Air Force believe for a moment that they could get it out of the silo and send it 6,300 miles to the garden? Well, they tested them. They took 51 of these missiles without warheads, and they took them to Vandenberg Air Force Base where they had reusable silos. These were not reusable. Okay, they aimed them at a small lagoon in the Marshall Islands that was about 6,300 miles off the coast of California. And then they fired them off. 97%.
All those weird looking things are platforms that can come down, and they can make a series of decks around the thing. And here you see the actual warhead and how it can separate from the final stage. And that weird looking thing going around it, that's the telemetry between the 2 sections. And again, from the top booster section to the main booster section, the telemetry goes down that thing that's on the side here. That's how wires go from one stage to the other, because there's no other interruption in the ring.
Problem with the Soviets is they had very, very poor accuracy. If they aimed a missile at Los Angeles, they didn't want to El Paso. And they knew it. The guys in the fishing boat. So, for 19 years...
And they can make platforms to work off of all the way down here. So you can get at every bit of this missile.
At the end of that period, in the early
Yet it can immediately open. And this one has the door half open, and that's how they had to store it in the SALT missile treaties. So it sits there with the door half open, and they can actually see it by satellites. And the nuclear warhead would sit in the black, that brown dome on the top. And it has a hole cut in it on the other side, which you can actually see from a satellite and see into it, but there is nothing inside that warhead chamber.
First of all, Minuteman missiles are smaller, but they're solid To the top of the outside stairs, wait for me. I've got a couple more comments over there.
Elevator
I'll
in
take
here.
any questions you
You do a fantastic job in this. I don't know how many times a day you have to do this.
I'm sorry?
How many times a day do you have to do this?
Me?
Well, that was more than a little bit interesting. And now we're going to go up top and have a look at how the doors open, have a look at the top of the warhead, and get back to looking at that engine. And these blast doors are made of I-beam, just I-beam. This is the bottom of the I-beam, and you're looking at the I-beam goes that way, and it's all just welded together. And then the outside has this machined edge all the way around the door, and that door becomes an air seal because there's another machined edge that sits still, and it's got a little rubber seal right here, like an O-ring. And when the two metals, they press really hard here, and this rubber O-ring makes an air seal. So that these doors are actually air sealed. Here's another one, actually air sealed. You see the big machine plate all the way around the door. And it lies into that machine plate there. And here's the last one to the outside, and again, you got that machine plate going all the way around the huge door, and there's the door frame. Pretty cool. Let's get out of here.
All right, folks, couple of things. Those blocks behind the door, they seem really out of place. When you go up to the viewing platform, you're going to see a cutout in the nose cone. I have never seen a missile launch with a cutout in the nose cone. What's that all about? When we wanted to build this as a museum, we told the Soviets, and they said, fine, build your museum, we don't care, but we're counting it as a missile site. And we said, but it's not a missile site. And they said, oh well, too bad. Okay, a year and a half later, after a lot of negotiating, we came to the following resolution. Block your door open in a half open position. When you're up there, you're going to see that door halfway across the silo. You can't launch a missile out of half a silo. That's why the blocks are there. The reason for the cutout in the nose cone was because they wanted to send their satellites over, which they are still doing today. Okay? To make sure there was no weapon in the nose cone. We agreed to those conditions, we got our museum, and we didn't have to give up a missile site. So sometimes negotiations work. Any questions? A couple other things. This site, they built this site from design to completion within 29 months.
Wow.
They built all 54 facilities within 36 months. Tell me why it takes 10 years to build a highway. All right, folks, if you have no other questions, the rest of this tour is self-guided. You can spend as much time out here as you like. When you're all done, if you want to go back in that last door on the left, that'll take you back into the museum. If you think of any questions while you're out here, bring them in. We'd be happy to answer them for you.
Why do
You've been in all. You have a question?
Yeah, why do you have the helo here?
That's what I drove to work this morning. Now, they would use that occasionally to transport the men back and forth. Okay? Folks, I want to thank my captain, my deputy. Thank you very much. You did a great job. All right, thanks for helping me.
Thank you, sir.
Enjoy the rest
Thank
of your
you.
day. Thank you very much.
Thank you very much, sir. Thank you. All right, let's go have a look at the blocks. So you're looking at the back side of a door, a very, very large door made of concrete that shields the top of the missile. This block of concrete right here is part of the SALT treaty, and it's not supposed to be here. It's keeping the door from being pulled apart. It used to have a shaft go from right there to that frame, and that's what sucks the door this way. There's so many people here, it's so crowded. This is one of 18 of these in this squadron, and there was 3 squadrons, so there was 54 of these missiles ready to go. 54 ready to go at all times. The section that goes on top of the last booster, and this is what holds the nuclear weapon right here. That bit of framing there, now it's a nuclear bomb. All right, so there's your top stage engine, and here's your bottom stage engines. Chris, check this out. So you got 2 fuel pumps, right? You got, go over here. So these engines, by the way, are steerable. They are steerable, right? So each engine can steer the 4 different axes by the top motor, or that's a stable. Here's this motor there. Yeah. That will actuate the motor like this, and then the motor can wag this way. They both go off the center. So you have that control right there, that actuator, I should say, and this actuator, and that's this thrust one like this. Yeah. And then each one has an up and down, and here's this guy's mounted up here. Here's your fuel lines in, Chris. Each bottom fuel pump has the 2 fuels going in, and here's your safety valve. This is the one that was added 10 years after the first of these. So this is the safety that had to have a code that originated from the president to get that thing open. And then, so the way these fuel pumps worked at 9,000, each one has an impeller. They worked at 9,000 RPM. And so how did they start up? How did they run? How did they start up? I'll show you. So over here, this line here takes bleed pressure from the combustion chamber. I mean, it's like huge pressure. Goes down and it runs into this chamber here. See this long pipe? And it goes right through it, and it goes here, and this is the impeller that spins the fuel pump. This section here is a set of gearing, and it runs each of the 9,000 RPM turbines, and I believe in total it's 170 gallons per second. So this is really hot air off the rocket spinning this. So this tube right here, this is an exhaust for the fuel pump. So hot rocket gases are coming out of this big time. Now, to get this thing fired up, to start it in the first place, they have to get gas coming down here really hard, and they do that by this section here is an explosive chamber, and inside this is a solid rocket fuel propellant, and they light it right here by electronics, or right there, I'm not really sure, but they light it. And for the first part of it, this thing becomes a controlled burn, and it just makes a ton of gas just compounding down here, which spins this thing like mad, which is what starts these engines. And that's how they run. And then the rocket itself runs the fuel pumps, which make this thing go. Pretty awesome. And then also figuring out these titanium bells are tapered rods all the way down. They're all one rod, and they're tapered all the way down. Pretty cool. So one of your fuels, this is one of your fuels, and that hydraulic mixing plate is right here. See how strong it is? It's got a bolt. Those look like 1-inch centers, exactly 1-inch centers, and every single one of them's got a safety wire on them. And they steer the rocket by controlling the missile plate. This is part of the steering of this rocket. And look, they grab right onto the mixing plate. Wow. I don't know what these two do. These are valves, and somehow this is almost like your fuel mixture control right here. Preset. These motors were not throttleable, and they were not able to restart in flight. You lit them and they took off. Pretty amazing that 2 completely separate systems with 2 separate fuel pumps would run equally enough to launch a 330,000 pound payload. Let's go look at the second stage motor. Again, you got your fuel pump sitting on the side here. You got your fuel pump exhaust bell here. This is your starter right here. Here's your starter. So they're going to light it with this little line right here, or this one of these two, or that one. These all attach electric lines, I believe. This little thing here and this little thing, this is not part of these are just little caps. But here's your solid fuel rocket. It hit here. Your main fuel pump is right behind this little guy here, spinning a shaft. Here's your gear reduction and your 2 fuels. These are the 2 fuel lines for this guy here. And I'm gonna guess and say the oxidizer is bigger than the fuel, because this one doesn't light off until outer space, right? You're way into You're in outer space before this one fires up. And well, this is the bottom of the fuel tank right here, I think. Wow, this is made of pretty heavy metal. Huh. And again, you've got a fuel mixture deal here. This is to control the mixture between you. Got, these are your two fuels. Oh, here you go. This is your, that's what's in this one right here. So that's fill out this line, that's the lower one, that's the big guy. Okay, so on the top one, see if it has a name on it. Oh, those things must have been added afterwards. But that's the name of the fuel right there. There's 3 different fuels that they tried in these rockets, and that's one of them. Hydro design or whatever. Oh, neat. They do have all the little lines labeled in this thing. Wow, we could look at this a little bit more closely. Oh, this is beautiful labeling. They should label the other one.
The hydrazone is the name of the fluid?
Yeah, it's the fuel. It's one of the fuels.
No, nitrogen and oxygen. Aren't they? The hydrogen, that's the... Is it not the name of the chemicals that with the explosion they touch each other? Isn't that not what that is?
No, that's the hypergol.
Not that?
No, that's the name of one of the fuels. Zine, that's a fuel. That's like some kind of a drain. I don't get what that is, some overpressure. But your mixing plate is right in there. This is your combustion chamber. Here's your where they make the most amount of force after combustion. Here's one fuel, the rocket fuel. It's got some kind of a bleed up here. No, it says it's going this way. This is a drain of some other valving system of it. Pretty cool. It was neat to learn how the fuel pumps work. It is neat to know that they're driven by the exhaust of the rocket. So let's see if we can get exactly how that comes off this one. Where do they get the line for that? It looks like this line right here. Huh. I'd like to find the line that powers, yeah, it's right here. That's the line of high pressure exhaust bleed that then goes through the burned out chamber of the starting chamber and then goes in here and spins the fuel pump and then exhausts through here and takes a bell which just comes out. Oh, this one looks like it's been test fired, or this material. Can't see that material rusting. Pretty neat. There's your mixing plate way in there. Pretty cool. One fluid came out of the big holes and the other fluid came out of the little holes. When the two fluids touched each other, they exploded, and that's called hypergolic reaction. Real simple. They must have had quite a few of these things sitting around. They must have had quite a few of these things driving around back in the day, hauling rocket fuel.
There's a little guy.
Where?
Is that the bee? That's the killer wasp. The killer wasp.
That's a killer wasp?
I think so. Yeah, they're the big guys in there.
Oh, you don't like that. We don't like that. All right, we're in Tucson, Arizona. You're on the road with Norm and Chris, and we're at a ballistic missile launching facility. An intercontinental ballistic missile. And that right down there would be a Titan II missile. There's the back of the door. Looks pretty fantastic. This facility was built in 29 months. I don't think they had much environmental oversight back in the day. Is a couple of military vehicles. That's what would have been operating around here. They had those Chrysler K-car wagons and pickup trucks, and that's what would have hauled the crew back and forth and done the security detail. Oh boy, this is cool. Here you go. There is your... This impeller spins 9,000 RPM, and it's powered by the rocket, bleed off from the rocket. It's very cool that they show a piece of that, how that comes apart. Both fuels get mixed up and come out. This is very, very interesting, this little piece right here. That is where the combustion happens. Right after that, the fluids get pushed through the chamber under high pressure, and as they come out, they touch each other and instantly ignite. This is all right next to the rocket. All of these little rooms and things are all right next to the rocket. Here's a book. If you want to launch one of these things, here's the manual. Cool signs.
You can get eaten by the dog.
Wow, it's all in here.
How are you? How are you? Doing great.
Wow. We bought the bag. We needed something for our laundry. Kind of a cool bag.
Very cool bag.
It's a very cool bag. It's all Blackbird. Here, flip it around. There, that's the cool side right there. And we're at the Titan Missile Museum, Phoenix, Arizona. No, yeah, Tucson, Arizona. It's a very cool bag.
Yeah, like a shoulder strap too.
And we're at the Titan Missile Museum in Tucson, Arizona. Here's their fuel truck, and it's plumbed. Basically, it's they keep it very, very close to the silo. That's the top of the missile right there underneath that glass frame. Oh, things have changed here. They used to have a little building where these engines were. And here is the engines. And these two here are on the bottom, stage one. Uh, 170 gallons per second is coming out of this fuel pump. So it all happened in here. And these are titanium, and the rods are fat. These are all different. They look like they're continuous, but they're actually not. On this side, they look continuous. Huh. Must be a couple layers of them. How do you get that? They're tapered rods. They tapered these rods. So, here comes one fuel at 170 gallons per second, and it goes into this ring, which is attached to that thrust plate, the diffuser. And let's get around. Okay, here's your fuel pump. Your fuel pump's in the middle of that. So here's how a rocket works. Let's have a look at how this thing works. You got two separate engines, two separate fuel pumps. The fuel pumps each have to pump two different types of fluid, and they can't touch until they get here because they explode when they touch. So they are, when the engines are running, these things are running off of, they bleed a little bit of pressure off the engine itself to spin the fuel pump at 9,000 RPM to pump 170 gallons a second. The exhaust from that stuff, boy, I'm gonna walk right in the middle of this engine. This, I believe, is the bleed air coming off the rocket, and it's coming through that line, and this is the exhaust of it. Somehow the turbine has got to be right there, and that turbine right here is spinning an impeller. It's spinning an impeller going right up. Oh no, it goes into gears. So the bleed air, I should go to the other side. I'll walk around. Beautiful shot of the diffuser plate down there. And here's your initial burn, and then right this little constriction is, I guess they figured all this out by trial and error, but they've constricted it to get more thrust out of it, and boom! Okay, this is pretty cool. So, see it a lot better on this side. Oh, you can see it much better from here. Much better from here. Okay, so we're at the top. If this rocket, would be looking straight down if we were as the camera is pointed right now. And that's one rocket engine, that's another rocket engine. That's one of the fuel pumps for this engine, and that fuel pump is for that engine. So let's just look at one of them for, you have two different fluids coming into the engine. When they mix over there, they explode, and that's the thrust. This one here has a very tricky set of valving in it, because the valving had an awful lot to do with the safety lock of this thing, so that nobody could come along and launch one of these things. The amount of electronics to operate, the valve in here was really quite a bit, because that was the safety. You could never have a terrorist grab one of these things and be able to launch it. They had to have codes, and the codes originated in the White House or in Washington, DC, and you just couldn't launch one of these things. So anyhow, so your two fuels are entering the pump down these things. They're going to pump 170 gallons per second, and it's gravity fed at this point. This 5-inch pipe, gravity fed into the pump. It's right at the bottom of the tank. I mean, this is obviously works really well. And there's an impeller in there spinning. There's an impeller in there spinning. Something like 9,000 RPM. Crazy. But this sucker is pumping 170 gallons per second. So how do they get it to work? Well, here's your two fuel lines going into, these are fuel lines going into the engine, and one's going to go into the back of the diffuser plate, and the other one's going to go into a ring all the way around the engine and enter the diffuser plate. And this is the plate right here. It's pretty strong, right? When these motors are running, the fuel pump is being powered by bleed pressure from the engine that it's supplying fuel to. And I'm trying to figure out exactly what it is on these engines. And as far as I can tell, it's this line right here coming down and going over to this module And let's look at it from the other side. Because that's the only line coming off these engines. And each side has one. And as far as I can tell, that is the only line coming off, so that's what it must be. And it makes a lot of sense. It enters this chamber here, and it comes down here, and it spins the pump. And I think there's one other thing that happens here, is to get this engine to fire. How does the fuel pump start at the very beginning? Well, it starts by a different rocket. It's just a solid fuel propellant deal, and I believe it's inside this deal. And I believe that's the ignition. And they ignite it, and this thing has a little rocket. There's solid rocket fuel in this chamber, I believe. I'm theorizing here, because I know they run somewhat like that. And then and this little tiny rocket fuel inside here burning, it puts a lot of exhaust down here, and that's what spins it, gets it going in the first place. And then once the engine is running, that bleed off is so high pressure down that line, it's coming down here and it keeps this thing spinning. And this is the exhaust of these two things here. That's the exhaust of the fuel pumps. So hot gases are coming out because it's gas that comes off of the combustion. These engines cannot be throttled, and they cannot be restarted in flight. They do control, they do vector a little bit, and this is the control that goes this way. Each one has two, one for this angle and one for that angle. So here is for up, down, and the other one is right here. And for the other engine, you got your guy right here, and the other one is right down here. So the engines are totally vectorable. They can move these bells around, they can push the thrust the way they want to, very quickly as well.